Okay, let's do a multi-drug CRI calculation here. So we've got 3 drugs that we're going to make for this patient. We've got the dosages right here, and we've got the concentrations of the drug right here. And here we've got our patient information. So we have a 40 kilogram patient who is on a fluid rate of 150 mils an hour and is currently on a 1,000 ml bag. Okay, so let's go ahead and calculate the drugs that this patient is going to be receiving. Let's figure out what the mils per hour of each of these drugs are. Okay, so let's start with the methadone. So we have a 40 kilogram patient, and we said the dose is 3 micrograms per kilogram per minute. Now remember, we're trying to figure out the mils per hour here. So let's go ahead and let's also convert this minutes to hours. So there's 60 minutes in 1 hour. Okay. And then let's put in our drug concentration, but oh, hang on here, there's a problem. So our drug concentration is in 10 mg per mil, but our dose is in micrograms. So we need to have a conversion factor here. So for each milligram, there are 1,000 micrograms. Okay, so now we can go ahead and we can input our drug concentration, which is for 1 ml, 10 milligrams. Okay, so this is going to tell us our mils per hour of the methadone. Okay, so let's go ahead and cross out all of the units that are in the numerator and denominator. So kilograms are gone, minutes are gone, micrograms are gone, and milligrams are gone. So all we're left with is hours and mils, and that's exactly what we're looking for, which is mils per hour. So 40 times 3 times 60 times 1 divided by the 1,000 and the 10 is going to give us 0.72 mils in 1 hour. Just in case you can't read that, 0.72 mils per hour. Okay, so we've got the methadone there. Now next, let's do the lidocaine. So our lidocaine, and again, we've got a 40 kilogram patient, and the dose is 0.6 milligrams per kilogram. And remember, I'm trying to cross out all the units except for the ones that we want. Okay. And then our dose, now when we look at it, sorry, not our dose, but our concentration. Our concentration is in mgs per mil, and this is fine because our dose is in mgs per mil, so we don't need a conversion factor. So we can just go ahead and put this in. Okay, so then we've got 40 times the 0.6 milligrams here, and then times 1, and then obviously just divided by 20, which is going to give us 1.2 mils per hour. So we've got 2 of our drugs now calculated. Okay, and let's just double check and make sure that we set up our calculations correctly. So kilograms are gone, milligrams are gone. Oh, and yep, we're left with mils per hour, so we've done that correct. Okay, so next let's do the ketamine. So the ketamine, again, we've got 40 kilograms times 5 micrograms. This one's in per kilograms per minute again. So we're going to have to put in those conversion factors, converting the minutes to hours. Okay, so 1 hour. And then again here, we've got our doses in micrograms, but our concentration is milligrams. So we're going to need that conversion factor of 1,000 micrograms in each milligram. Okay, and then we can input our strength of the drug, which is 1 mil is 100 milligrams. Okay, so let's figure out how many mils per hour that is. So let's cross out all of our units that we don't need. They're in the numerator and denominator. And where's my minutes? There they are. And then our milligrams, and that's leaving us with mils per hour. So we set it up again correctly. So that's 0.12 mils per hour, because 40 times 5 times 60, ignoring the ones, divided by 1,000, divided by 100, okay? And that gives us 0.12 mils per hour for ketamine. Okay, so let's go ahead and add this to the fluid. Now we said we've got 1,000 ml bag here, but let's just say that your patient has already been on fluids for 2 hours. So we said that our fluid rate was 150 mils an hour. If the patient was on 1,000 ml bag and they were getting the dose right here of 50 mils per hour times 2 hours, that would give us 300 mils, okay? So we originally started with 100 mils, and now there are 300 mils gone. So it's 1,000 minus 300, which is gonna leave us with 700 mils to put all these drugs into, okay? So let's go to the next page here, okay? So we've got 700 mils, okay? And our fluid rate, we said, was 150 mils an hour. Okay. So how long is this 700 mils going to last us? So we can either use ratio and proportion. So let's say 1 hour, we said, was 150 mils, is equal to X hours in 750 mils. And then we're going to cross multiply, or we can also use dimensional analysis. Oops, sorry, 700, not 750, so 700. If we use dimensional analysis, we can go 700 mils times 1 hour is 150 mils. Now, if we go through and solve for X here, X hour, we're going to cross multiply, so we have to get X alone. We're solving for X. So equals 700 times 1 divided by 150. Now you see how these are actually the exact same thing. 700 times 1 hour divided by 150. So you can use dimensional analysis or ratio and proportion to solve this part right here. So we go 700 divided by 150. So 700 divided by 150 gives us a whole bunch of decimals, which we're just going to round up to 1 decimal point. So 4.666 ends up being 4.7 hours. Okay, so now we know how many hours we need to multiply our drugs by. So we said for our methadone, we needed 0.72 mils per hour. Our lidocaine, we said we needed 1.2 mils per hour. And for our ketamine, we said that was 0.12 mils per hour. Now what we do is we're going to multiply all of these by 4.7 hours, and that's going to give us how much drug needs to go in these bags. So 0.72 times 4.7 equals 3.38, so 3.4 mils. And 1.2 times 4.7 equals 5.64 or 5.6. For our purposes here, we're just going to be rounding everything to 1 decimal point. And 0.12 mils an hour times 4.7 hours equals 0.56, so 0.6 mils. So now we add all of these together. 3.4 plus 5.6 plus 0.6 gives us 9.6 mils of drug. Okay, so that means that we need to make space in this 700 mils for these drugs. So 700 minus 9.6. Okay, so we go 700 minus 9.6 is going to give us 690.4 mils of fluid. Okay, so because this bag is already running and it's already there, we're going to remove 9.6 mils of drug, and then we're going to add all of our methadone, lidocaine, and ketamine, which is going to give us a total volume of 700 mils. So there you have a little run through on how to figure out fluids over time, as well as calculating a CRI and adding it into a pre-existing patient fluids.